Look up at the night sky and you'll see a universe filled with galaxies. Vast islands of stars shining across unimaginable distances. Many of these galaxies are cosmic factories, constantly forging new stars from enormous clouds of gas and dust. But here's the mystery. Some galaxies suddenly stop. They still contain billions, sometimes trillions, of stars. Yet the creation of new stars mysteriously shuts down. What could possibly silence something as powerful as an entire galaxy? In this journey across cosmic scales, we'll explore how stars are born, why galaxies run out of stellar fuel, and what strange forces can transform vibrant galactic nurseries into quiet stellar graveyards. And along the way, we'll uncover a surprising truth about our own cosmic origins. Across the vastness of the universe, galaxies glow like enormous islands of light drifting through cosmic darkness. Inside these luminous systems, countless stars are born from clouds of gas and dust. For billions of years, these stellar nurseries keep producing new suns. But then, strangely, some galaxies simply stop. At first glance, galaxies seem like endless factories of stars. Massive clouds swirl through them like cosmic weather systems. Gravity slowly squeezes these clouds together, igniting new stars again and again. Yet in many galaxies, that cycle suddenly goes quiet. Astronomers scanning the universe have noticed something puzzling. Some galaxies sparkle with young, bright stars that burn hot and blue. Others appear older, dimmer, and reddish, filled with ancient stars nearing the end of their lives. In those systems, the stellar assembly line has somehow shut down. Imagine a bustling city that suddenly stops building new houses. The buildings remain, the streets stay lit, and life continues. But no new neighborhoods appear, no new construction begins. In the same way, these galaxies remain full of stars, yet no new ones emerge. So the question begins to echo across cosmic scales. Why would a galaxy, rich with billions of stars, suddenly stop creating more? What invisible switch turns off one of the universe's most powerful engines? To begin answering that mystery, astronomers first had to notice something strange about the colors of galaxies themselves. When astronomers map the universe, galaxies don't all look the same. Some shine with a brilliant bluish glow, almost like cosmic fireworks frozen in time. Others appear softer, redder, and calmer, like ancient embers slowly fading. And that difference in color hides an important cosmic clue. Blue galaxies are bustling with activity. They contain many young stars that burn extremely hot and bright. These stars shine with a bluish light, much like the intense flame of a welding torch. Wherever astronomers see blue galaxies, they know new stars are still being born. Red galaxies tell a completely different story. Their light comes mostly from older, cooler stars that formed billions of years ago. It's similar to the way a campfire glows red after the bright flames die down. The fire isn't gone, but it's no longer blazing. What makes this discovery fascinating is that red galaxies are everywhere. Across galaxy clusters and deep cosmic surveys, astronomers see them again and again. These systems still contain billions, sometimes trillions, of stars, yet almost no new stars are forming inside them. So the universe seems to separate galaxies into two great families. One group is vibrant, blue, and actively forming stars. The other is quiet, red, and strangely inactive. To understand why this difference exists, scientists had to zoom much deeper, down to the tiny particles where stars are actually born. To understand why galaxies stop making stars, scientists had to zoom in, far beyond the scale of galaxies, clusters, or even entire solar systems. They had to look at the smallest ingredients that build stars in the first place, because every star, no matter how massive, begins with something incredibly simple, just tiny atoms drifting through cold cosmic clouds. Most of these atoms are hydrogen, the lightest and most common element in the universe. Imagine an enormous fog made of invisible particles floating through space. At first, the atoms barely notice each other, drifting slowly in the darkness. But gravity is always at work, quietly pulling them closer together. Over time, these atoms gather into dense clouds known as molecular clouds. Inside these clouds, particles collide more and more often. Each collision transfers energy, compressing the gas tighter and tighter. Like snow being packed into a snowball, the cloud slowly grows denser. Eventually, gravity takes control. The cloud collapses inward, and the pressure at its center rises dramatically. Temperatures climb until atomic nuclei begin to fuse together. At that moment, a new star ignites, like a cosmic engine turning on. But here's the crucial detail astronomers began to realize. Stars can only form if these cold clouds of gas exist in the first place. Without that raw material drifting through a galaxy, the process simply can't begin. And that raises a fascinating question about entire galaxies themselves. To better understand this idea, scientists often look at something closer to home. Planetary systems form through a process surprisingly similar to star formation. Both begin with clouds of gas and dust swirling through space. And both depend on how much material is available to keep building. When a young star forms, it is surrounded by a spinning disk of leftover gas and dust. Inside this disk, particles collide, stick together, and gradually grow. Tiny grains become pebbles, pebbles become rocks, and rocks become planets. It's a slow cosmic construction project unfolding over millions of years. But that construction only continues while the raw material remains. If the disk runs out of gas and dust, the process stops. No more planets grow, no new worlds appear. The system becomes stable, quiet, and mostly unchanged. Galaxies follow a remarkably similar rule. Instead of forming planets from disks, they form stars from enormous gas clouds. As long as cold gas flows through the galaxy, new stars can continue to ignite. But if that gas disappears, the galaxy loses its ability to create new suns. So the mystery begins to sharpen. Galaxies don't stop forming stars randomly. Something must be removing or altering the gas they depend on. To investigate this, astronomers turn to powerful telescopes that can see where stars are still being born. To uncover where stars are forming, astronomers can't rely on visible light alone. Much of the action inside galaxies happens hidden behind thick curtains of dust. So scientists turn to telescopes that observe the universe in many different wavelengths. Each one reveals a different layer of the cosmic story. Infrared telescopes are especially powerful for this task. They can see the faint heat glowing from dusty star-forming regions. Even when clouds block visible light, infrared waves slip through like night vision goggles for the universe. Suddenly, hidden stellar nurseries appear, where darkness once seemed empty. Ultraviolet observations reveal another clue. Young stars burn extremely hot, blasting out energetic ultraviolet radiation. When astronomers detect strong ultraviolet light in a galaxy, it's a sign that new stars are actively forming. It's like spotting bright sparks flying from a cosmic furnace. Radio telescopes add yet another piece to the puzzle. They can detect the cold molecular gas drifting between stars. These radio signals reveal enormous reservoirs of hydrogen, the raw fuel for future star formation. In some galaxies, that fuel is abundant, but in others, something strange appears. Astronomers find galaxies glowing with ancient stars, yet almost no cold gas left inside them. The stellar factories are still there, but the fuel tanks seem nearly empty, which leads scientists to the deeper physics behind star formation itself. At the heart of star formation lies a simple requirement. Galaxies must contain large amounts of cold molecular gas. This gas acts as the raw material from which stars are built. Without it, the cosmic assembly line simply cannot continue. Cold gas behaves very differently from hot gas. When gas is cold, its atoms move slowly and can clump together under gravity. It's similar to how water vapor condenses into droplets when the air cools. The cooler the gas becomes, the easier it is for gravity to pull it into dense clouds. But if the gas becomes too hot, everything changes. Hot atoms move rapidly, spreading out instead of gathering together. Imagine trying to form snowballs during a powerful windstorm. The material keeps blowing apart before it can stick. Astronomers discovered that many galaxies lose their cold gas in several ways. Sometimes it gets heated to extremely high temperatures. Other times, powerful galactic winds push the gas out into intergalactic space. And in some cases, the galaxy simply uses up the gas over billions of years. Once that supply disappears, star formation slows and eventually stops. The galaxy still shines with billions of existing stars. But without fresh fuel, no new stellar generations can appear. And yet, this same process once worked perfectly in the region where our own sun was born. About 4.6 billion years ago, our corner of the Milky Way looked very different. Instead of planets and a bright yellow star, there was only a vast cloud of gas and dust. This cloud drifted quietly through the galaxy, cold and dark. Yet hidden inside it was the potential for an entire solar system. Something eventually disturbed that cloud. Perhaps the shockwave from a nearby exploding star rippled through the region. Like a sudden gust pushing leaves together, gravity began pulling the gas inward. The cloud slowly collapsed, growing denser and hotter at its center. As the collapse continued, the center ignited into a newborn star, the Sun. Around it, the remaining gas and dust flattened into a rotating disk. Within this spinning disk, tiny particles collided and stuck together. Over millions of years, those grains grew into asteroids, moons, and planets. The process wasn't unlike watching an ice skater spin. When a skater pulls their arms inward, their rotation speeds up. In a similar way, as the collapsing cloud shrank, it spun faster and faster. This motion helped shape the disk where the planets eventually formed. But here's the fascinating part. This entire chain of events was only possible because our galaxy was actively forming stars at the time. The Milky Way still had plenty of cold gas drifting through its spiral arms, which raises an intriguing question about the larger cosmic picture. The birth of our sun wasn't just a local event in a quiet corner of space. It was part of a much larger cycle happening across the Milky Way. Stars forming inside galaxies create the environments where planets can emerge. Without those stellar nurseries, worlds like Earth would never exist. Every generation of stars enriches the universe with new elements. Inside their fiery cores, stars forge heavier atoms like carbon, oxygen, and iron. When massive stars explode as supernovae, those elements scatter across space. They become the ingredients for future planets, oceans, and even living organisms. Earth itself is built from this cosmic recycling process. The iron in its core, the oxygen in its atmosphere, the calcium in our bones, all of it was forged inside ancient stars long before our planet formed. In a sense, life on Earth is made from the ashes of earlier stellar generations. That means active galaxies are more than just star factories. They are also chemical laboratories constantly enriching the universe. Each new star increases the chance that somewhere, a habitable world might appear. A quiet galaxy with no star formation becomes far less creative. So when galaxies stop making stars, something profound happens. The creation of new planetary systems slows dramatically. Fewer new stars mean fewer chances for life-bearing worlds to emerge. Which brings us to the larger forces that can silence entire galaxies. When astronomers look at galaxies across the universe, they notice that star formation doesn't simply fade away by accident. Often, powerful events reshape the entire galaxy. These events can disrupt gas clouds, heat the interstellar medium, or even eject material into space. On galactic scales, small changes can ripple outward like storms across an entire world. One of the most dramatic triggers is a collision between galaxies. Galaxies move slowly through space, but gravity eventually pulls some of them together. When they merge, enormous tidal forces twist their structures and stir their gas. For a time, star formation may explode in a brilliant cosmic fireworks show. But this burst of activity often burns through gas quickly. Imagine a hurricane drawing energy from warm ocean water. Once that energy source is exhausted, the storm weakens and fades. In the same way, a galaxy merger can consume vast reservoirs of star-forming gas. Another powerful influence lies at the centers of many galaxies. There, supermassive black holes quietly sit, sometimes billions of times heavier than the Sun. When matter falls into these monsters, they can release enormous jets and radiation. Those outflows can heat or blast away the cold gas needed to form stars. Over time, these processes transform vibrant galaxies into quiet stellar cities. The stars remain, orbiting peacefully for billions of years, but the raw material that once fueled new stellar births has vanished. And to understand why this became common across the universe, scientists had to look back in time itself. To understand why many galaxies grow quiet, astronomers had to look deep into the past. When telescopes peer billions of light years away, they are also looking billions of years back in time. And what they see is a universe that was once far more energetic, a universe where galaxies were forming stars at astonishing rates. In the early cosmos, gas was everywhere. Huge rivers of hydrogen flowed through young galaxies like cosmic fuel lines. These galaxies were turbulent, crowded, and extremely active. Stars ignited across them like sparks in a roaring fire. Astronomers sometimes call this period the cosmic noon of star formation. Roughly 10 billion years ago, galaxies were producing stars much faster than they do today. It was the busiest era of stellar birth the universe has ever seen. Almost every galaxy seemed to be alive with activity. But over billions of years, something began to change. As galaxies kept forming stars, they slowly consumed their gas supplies. Some galaxies lost gas through powerful winds or violent interactions. Gradually, the once rich reservoirs began to thin, and as those supplies faded, the universe itself started to quiet down. Many galaxies transitioned from vibrant stellar nurseries into calm stellar archives. They still shine with ancient stars formed long ago. Yet this transformation raises a deeper reflection about the life cycle of the cosmos itself. When astronomers study galaxies that no longer form stars, they are witnessing a kind of cosmic aging. These galaxies still glow with the light of billions of suns, but their brightest days of creation have already passed. They have transitioned from vibrant nurseries into quiet stellar archives. Yet this silence does not mean the universe has stopped evolving. Elsewhere, new galaxies still swirl with clouds of cold gas. New stars continue to ignite in distant corners of the cosmos. The universe is vast enough that creation and quietness happen at the same time. In many ways, galaxies resemble living ecosystems. Some regions burst with activity, growth, and renewal. Others become stable environments where little changes for billions of years. Across cosmic time, galaxies move through these phases, like seasons in the life of the universe. And somewhere within one of those active regions, billions of years ago, our own story began. A cloud of gas collapsed, a star ignited, and a small rocky world formed nearby. From that world, conscious beings eventually looked back into the sky, trying to understand the vast processes that shaped their existence. So the quiet galaxies scattered across the cosmos carry an important reminder. The universe is not static. It is constantly transforming. Stars are born, galaxies evolve, and new worlds continue to appear. And somewhere, in the endless darkness, the next cosmic story may already be beginning.